Okay, let's step through the computation that happens in value iteration. So what we have here is a MDP with two states, A and B. In each state there are two actions, action 0 and 1. We see here at the bottom is the final states, A and B when there's 0 time steps left. And then this layer here, we see the Q states when there's 1 time steps left. This is the regular states with 1 time step left, Q states with 2 time steps left, and the regular states with 2 time steps left. So let's start filling this in. So with 0 time steps left being in state A, we get a value of 0. With 0 time steps left, state B, we get a value of 0. And to compute the value over here, this is being in state A, having taken action 0, and there being 1 time step left. So in state A, taking action 0, we get with 50% chance a transition to state A and a reward of 2.0. So we have 0.5 times 2.0. And there's no discounting here, so plus gamma, which is 1, times the value at the next state, which is A, and the value of that state is 0. And then we have a 0.5 probability of going to state B. For this transition, the reward is -1, so we have plus 0.5 times -1, plus the value at the next time, discounted, but our discount factor is 1, so no discounting. The value at the next state is 0. So here we go. This is our value for this node. Now here we're in state A. Just took action 1. So we're working with this part of the table here. There's a 50% chance that we go to A and 50% chance that we go to B. So 0.5 times the reward for A plus the value we get at A plus 0.5 times the reward we get for B plus the value we get at B. So what are the rewards and the value here? So to go from A with action 1 into A, that's this row over here, we get a reward of 1. Landing in state A with 0 steps left gives us a value of 1. Then if we were to go to B, we get a reward of 2.0, and the value at the next state is 0. Here's our value. Then here we have, we're in state B, we just took action 0, so we are in this section of the table here. There is 0 probability that we transition to state A, and probability 1 we transition to state B with a reward of -1. So we have 0 times minus 2.0 plus the value at the next time is 0 plus 1.0 times the reward of -1 plus 0 at the next time. That's our value here. Here we're in this part of the table. We're in state B, took action 1. We have a 10% chance of going to A, 90% chance of going to B. So we have 0.1 times, and then when we go to A, we get -3.0 instantaneous reward, 0 at the next time. When we go to B, which is probability 0.9, we get a reward of instantaneous reward of -1.0 plus 0 value at B, and this is our value here. Alright, now take it one level up. Here we're in state A, there's 1 time step left. We have 2 actions to choose from, 0 and 1, and since we maximize the expected sum of rewards, we'll take the action that leads to the highest expected sum of rewards, so that's action 1 in this case, which leads us to expected reward of 1.5. Here in state B, we get to choose from 2 actions. We pick the one with the highest expected sum of rewards, which is action 0, which gives us a value of -1.0. Here we go. Okay, now we're again one level up in the value iteration process here. here we are in state A. We took action 0, and we are now in this part of the table. So there's a 50% chance of going to A, 50% chance of going to B. So we have 0.5 times the reward for going to A is 2.0. Plus, if we go to A, we will get future rewards on expectation of 1.5, so plus 1.5. And then there's a 50% chance of going to B, in which case we get an instantaneous reward of minus 1.0 and a future expected reward of also minus 1.0. That's our value here. Here we're in the Q state where we are in state A and have taken action 1. So we are in this part of the table. 50% chance we go to A, for which we get an instantaneous reward of 1.0 and a future expected sum of rewards of 1.5. And a 50% chance we go to B, for which we get an instantaneous reward of 2.0 and a future expected sum of rewards of minus 1.0. That's our value here. Here we're in the Q state where we are in state B and have taken action 0. So we have to look at this part of the table here. There is a 0% chance we transition to state A. So let's just leave that part out. Then there's a 100% chance to go to state B, in which case we get a minus 1.0 instantaneous reward plus a minus 1.0 expected future sum of rewards. That's this value, and then here's the last one in this level. We're in state B and took action 1. So it's this part of the table. There's a 10% chance that we transition to state A. For that transition we get an instantaneous reward of minus 3.0, expected future sum of rewards of 1.5, which we read off over here. And then we get with 90% chance a transition to state B, for which we get an instantaneous reward of minus 1.0 and a future sum of rewards of also minus 1.0. So plus minus 1.0. All right. Now here at the top layer, we're in state A. We're going to choose between two actions, 0 and 1. Action 1 is the highest expected sum of rewards, so that's the value we're going to take for this state, 1.75. And then here at the top, we have again the choice between two actions. We're in state B. The one with the highest expected sum of rewards is action 1, which leads us to an expected sum of rewards of minus 1.95. All right, so this is it. Let's now submit and see if we got it right. There we go. And indeed, we got this completely correct.